Hi, this is Algebra 2, Lesson 68. We're going to talk about scientific calculators, scientific notation, and powers and roots. We're going to start by figuring out how to punch these scientific notation equations into your calculator. When you're doing problems with your calculator, you need to start by thinking these problems through so that you know if your answer is reasonable. So we know that negative 40,652 times 10 to the negative 8 is, we can move this guy, the decimal up 1, 2, 3, 4 places. So this is actually approximately 4.1 times 10 to the negative 4th, right? Because we moved the decimal up 4 times. This one, we're moving the decimal back, so 1, 2, 3, 4 times. So this is going to be approximately the same as 3.2 times 10 to the 11th. So we know we're going to be multiplying these, and we just need really rough estimates. Your book does really close estimates. We want something that's pretty rough. This is going to be approximately negative 12 to the 10 to the 7th, right? Which would actually be approximately 1.2 times 10 to the 8th. When you punch this into the calculator, you're going to find something close to this, not exactly that. This is a very rough estimate, so it's going to come out to something close to that. Now, plugging things into your calculator is going to depend on your calculator. I have a Texas Instrument 82, which actually came out in 91. The way I punch things into the calculator are not necessarily going to be the same way you punch your things into the calculator. It's certainly not the same way the book says. So in my calculator, in order to find the answer to this, I would hit parentheses minus 40652, the second function button, and I find the little blue numbers that say EE, and then I'd hit the negative 8, close parentheses, times, open parentheses, 0.000324, and now I need to do the scientific notation, so second EE to the 15th power, close parentheses, and I hit enter. And the answer I got is minus 131712480. So to put this back into scientific notation, we do 1, 2, 3, 4, 5, 6, 7, 8. And we get negative 1.317 times 10 to the 8th. Which is close enough. Okay? We were in the right ballpark. Now, you're just going to have to play with your calculators and figure out how to get this. Some calculators have exponent buttons where it says EXP. Some of them say Y to the X. Mine has a second function button and a little EE. So you're just going to have to play with your calculator and figure out what works. Okay, let's try this one. We're going to simplify 40,652 times 10 to the negative 8th by 0.000324 times 10 to the negative 15th. Once again, we're going to estimate, and these just happen to be pretty much the same numbers as we used last time. So this is going to come out pretty close to 4.1 times 10 to the negative 4th. This, we pull everything this way, and it's going to come out really close to 3.24 times 10 to the 11th. This time we're dividing instead of multiplying, so we subtract these, and it's going to be approximately 4.1 over 3.24, which is a little more than 1, but it's less than 2. So we're going to say it's approximately 1 times 10 to the, and we're going to subtract -4 minus 11, -15. So it's somewhere between 1 and 2, and it's 10 to the -15. That's the ballpark answer, and that's as close to an estimate as you need to get. Just so you know that the answer that you get with your calculator is reasonable. Okay, so we're going to plug this into the calculator. And the answer is 1.26 times 10 to the -15. Okay? Okay, powers and roots. This is a little bit of review from Algebra 1. Rational numbers can be written as a fraction or a ratio of integers. So 0.43 is a rational number because you can rewrite it as 43/100ths. 3.43 is a rational number because you can rewrite it as 343/1000. Oh, that would be over 100. Sorry. 0.33 repeating is the same as 1/3. 4.6 repeating is the same as 4 2/3, which is the same as 14/3. Every rational number can be written either as a decimal that has a finite number of digits, like 4.687254, and then it stops, or as a decimal whose digits repeat in a pattern. So that would include 0.33333333, or 4.66666666, or something like 4.672672672672672672. Okay? If the digits repeat in a pattern, then it counts as a rational number. Irrational numbers have an infinite number of digits in their decimal places that are not in a repeating pattern. So that would include the square root of 7, the 4th root of 5, the 9th root of 3, pi, the natural log, which we call e. These are all irrational numbers that have an infinite amount of decimals that do not repeat. Okay, your scientific calculator will give you an approximation of any rational or irrational root or power of any positive number. So we could raise 23 to the pi power, or take the pi root of 23. So we're going to evaluate 50.42 to the 3.28 root. Okay, this is once again just playing with your calculator and figuring out how to punch it in. In the calculator the book uses, you'd punch in the 50.42 and then an inverse y to the x power, and then 3.28 and then equals. On my calculator I put 50.42 and the inverse button, and then I have to actually punch in 1 over 3.28 and enter. So my inverse button actually looks like a carrot top. So on my calculator I punch in 50.42 and this little button that looks like a carrot top, parentheses 1 over 3.28, close parentheses, and enter. Okay, so this is once again playing with your calculator and seeing what works. The answer you come up with is 3.304. Okay? To get 9.26 to the 4.58 power, I do 9.26, a little carrot top, so to the power of 4.58, and then enter. And the answer I get is 26,734.89. Okay? If you do 9.26 to the negative 4.58, I do it the same way, inverse, or to the power of rather, negative 4.58, and I hit enter. And the answer I get is 3.74 times 10 to the negative 5. So, once again, this is just a matter of playing with your calculator until you figure out what order to push the buttons. And that is it for this lesson. Have fun button pushing. Let me know if you have any questions with the practice problems.